Welcome to this episode of the AI Show, where we talk about GreenerAI with Buchanan. Hi, Will. Welcome to the AI Show. And can you introduce yourself and tell us what you do at Microsoft?
Hey everyone, my name is Will Buchanan. I am a PM on the Azure machine learning team, specifically focusing on user experience and decarbonization of AI.
That is great. So what are some of the problems that you're solving?
So I've been working on something called GreenAI, which has become a recent hot topic in the news. And it's really specifically focused on providing a set of tactics that data scientists and developers can use to reduce the carbon footprint of their machine learning workloads.
That is great and very timely, indeed.
It is. We're out of time, in fact.
All right. Can you tell us a little bit more about the services, the GreenerAI services, and what we do?
Certainly. So within Azure Machine Learning, we have launched a set of resource metrics which provide transparency into the computational costs as well as the energetic costs of your workloads. And really, we're trying to provide transparency to help empower developers to make decisions about when and where they should be running their models and how to optimize or make decisions which would be more environmentally friendly.
Mm-hmm. And how can developers do that? Make more informed decisions?
The first step is transformation on transparency around those metrics. So we're providing those metrics to help users understand the costs of the models, but soon we also have a set of recipes or samples that any practitioner can use and start understanding the savings of their workloads. So I
Mm-hmm.
can walk through that in a second.
Great. We would like to see it.
Sure. And before I dive in, I will give a bit of context.
Go ahead.
So I've been leading an initiative called GreenAI at Microsoft, and it has about 200 people in it across the company. And the reason we're doing this is because you really can't manage what you can't measure. So we're showing a set of early research and innovation that's happening across Microsoft. So we're going to talk about some new capabilities, as well as a few different use cases and validation tactics, and then a few tips on getting started. In terms of where we are today, we're in a state of something known as red AI, and we've created a computational megafauna. So you have state-of-the-art approaches that are buying incrementally better results with high hidden costs. So computational costs have increased in machine learning about 300,000 times from 2012 to 2018. And according to an article by Wired, only about 11% of firms are seeing what can be called a significant return on investment for their workloads. And it's pretty shocking when you think about that. Some recent studies have shown that the GPT-3 training emits as much carbon as 3 round-trip transcontinental flights from San Francisco to New York. And Emma Struble, about a year or two ago, also published a seminal paper which compared a transformer model with a round-trip flight or a human life or a US car. So a 213 million parameter transformer model training consumes as much carbon as 5 cars, including gas. So as you can see in this chart, we have surpassed what could be seen as Moore's law, and we're in more of the extreme modern era of computation where it's doubling about every 3.4 months. And the AI market is going to grow about 44% annually through 2025. And we believe that there will be a point of inflection where there are diminishing returns, where the marginal cost benefit ratio are no longer worth the additional investment. And a bit of background on AI pipelines. So it consists of both training and inference. In training, you are teaching a model how to make predictions based on existing data. And generally, you're doing long runs and a few of them. And then when you go to scale, you infer your model, and you're applying this trained model to make predictions from data that it has not seen before. Generally, it has short runs and lots of them. And emergently, there is specialized hardware such as GPU, which is optimizing your workloads there. And they are often power hungry, consuming about 300 watts on average. As I mentioned earlier, it's a pretty hot topic in the media these days. Had a chance to chat with Timnit Gebru, who published the Stochastic Parrots paper, and she's really saying how it is past time for researchers to prioritize energy efficiency and cost so that we can reduce environmental impact and increase equitable access to resources. So you can think of the AI industry in some ways as similar to the oil industry. Once you mine and refine your data, it can be highly lucrative, and it seems that this metaphor could extend even further. And the way that we're addressing this is through a cost metrics framework. In terms of the costs, we want to expose both monetary, the computational runtime, the energetic costs, as well as utilization for both training and inference. And it's important with training because only about 12% of the models that you're making actually make it into production. And for inference, according to an article by NVIDIA, it accounts for about 80 to 90% of the carbon cost of a model. So the vision that we're working towards is an operational lifecycle analysis monitoring toolkit. So you can assess these different cost frameworks for both training and inference, and then set a set of triggers or tools you can start to optimize your return on investment. So the first capability that we've done, you can see in Azure Machine Learning Studio. In the user interface, you can add an opt-in metric to see the GPU energy cost for your runs. This helps you find the most energetic culprits, and then you can sort to discover which ones are the most expensive. We're also offering the same capabilities for both utilization, GPU, and memory. Next, you can see some additional screenshots in the monitoring tab, which is in preview. You can view a real-time plot of your GPU energy usage broken down by node. And you can also see CPU utilization, GPU utilization, and memory, and of course, energy. And so we've done a study where you perform a batched inference run, and we calculated the cost per million inference, which is the standard framework for inference. So it consumes about 13.8 kilowatt hours. And that's about half of a US home's daily energy consumption.
Oh, wow.
Yeah, it's crazy.
It is.
And so if you were to convert that to greenhouse gas equivalencies, that'd be about the same as 24 miles driven or 11 pounds of coal or a gallon of gas. So you can imagine this really adds up over time. So the analysis we did was for the BERT model using a TensorFlow framework on a V100 with 32 floating point precision and 16 batch size of 16. We ran it for 2.5 hours and we calculated the throughput as well as the energy cost, and then we extrapolated that for 1 million inferences. So as part of our work, we've been working with NVIDIA on something called the Triton Inference Server, and this is specifically designed for high throughput inference workloads. It comes with a number of benefits, such as model concurrency, where you can load multiple models or copies of that model onto a GPU and then execute them simultaneously. Another exciting feature is dynamic batching, where you can dynamically group together your requests on the server side to maximize your performance. And mixed weights precision. Due to the vanishing gradients phenomenon during your training on a backward pass, your models you typically trained using floating point 32 precision. However, given for inference, only the forward pass is necessary. You can use a lower precision, such as 16, and Triton allows use of both of these. So on a similar analysis, we found that if you used mixed weight precision, you can cut your cost by greater than 50% just by switching from floating point 32 to 16 using the Triton Inference Server. And you can see the cost per million inference is significantly less, almost a third, and GPU power consumption is from about 75 to 60 watts.
This is great.
Something else we've also been working on and will soon be releasing, there is work with the NVIDIA Model Analyzer. So you can analyze and develop the optimal configurations for your model. And we also charted the relationship between power efficiency and GPU utilization. And so if you use Model Analyzer to optimize your configuration, you can reduce your cost per million by about 12.6x. And here you see the chart with the baseline there. So the baseline is compared against ORT and CUDA as the backend versus the TRT backend optimized by Model Analyzer. So using the model analyzer can automatically maximize both your GPU utilization and your throughput, and consequently save energy. And finally, an additional case study that we've done. For the image classification scenario for training, we compared two different convolutional neural networks, Inception v3 and DenseNet. And both of these classify images with greater than 75% accuracy on your ImageNet data set. And so we compared these two models for both energy usage and cost savings to help determine which models give you the results you need at the lowest cost, both monetary and environmental. And so we found that Inception v3 outperforms DenseNet in terms of accuracy, coming at about 10% higher. Also costs about 13% less and uses 20% less energy and about 10% less training time. So really key to this, and this is the foundational tactic, is choose the right tool for the job. Start to think about the networks that you're choosing and the costs that incurs for your business.
You're not only saving the environment, but you're also paying less, which is great.
Yeah, I agree. It's the real business case for this work. So we're just getting started doing GreenerAI, and we hope to bring additional people in to work on this. And so we'd like to work with any customers to define what carbon awareness and energy efficiency might need for their organization. And specifically, we'd like to point you to the Triton Inference Server to get started doing that. And also, we will share some recipes and samples to help compare these cost-benefit trade-offs. And I did want to throw in a plug for the Green Software Foundation, where we're starting to define this concept called a software carbon intensity specification, and that is currently the alpha version is live. So if you look up Green Software Foundation on GitHub, you will see some really exciting work there. So that concludes my presentation.
Great, thank you so much. This is really exciting. And where people can learn more about GreenerAI?
So we have a blog on the tech community, which outlines some of this that I showed here, specifically the resource metrics. And also, I believe we're posting the link to the Triton Inference Server. So I think that's the best starting point, but stay tuned. We'll have a lot more exciting news soon, and especially with the Green Software Foundation.
Thank you for joining, Will, and thank you for telling us about the GreenerAI. We'll see you next time.